Hey guys, we're going to talk about this concept right here, being able to compare and contrast glycogenesis, glycogenolysis, lipogenesis, and lipolysis, proteogenesis, and proteolysis, and then this final last term here, gluconeogenesis. These are all metabolic processes that occur as a result of either high blood glucose levels or low blood glucose levels. Uh, Down here, this link right here will take us to a resource we're going to take a look at in just a second. But here on my are the definitions for what these terms mean. Gluconeogenesis is the creation of glucose from other substrates such as amino acids and fatty acids. And these things right here, along with glycogenolysis, lipolysis, proteolysis, they all occur in response to low blood sugar levels, also known as hypoglycemia. The prefix hypo means low or below. Glyce always refers to the glucose or glycogen, and the suffix emia means blood. So if you put all that together, it's low blood sugar. So again, just remember, science and terminology and vocabulary in science is a lot of times a hodgepodge of prefixes and suffixes all squished together to create new meaning. So this is no different. In a hypoglycemic state, when glucagon is going to be released, after you haven't eaten in a long time, considered what's called the fasted state, several processes can start taking place in order to maintain homeostasis and provide energy for your body. Let's take a look at this feedback loop here. Click on this link here. It'll take you to this diagram here, which is what we should be going over in class as well. Insulin, whenever blood Okay, let's start over here. Exercise or starvation causes a decrease in blood glucose because if you haven't eaten in a while, your blood glucose level will be down. And if you're exercising, you're going to be using your blood glucose and spinning it for energy. Well, as a result of that, glucagon is released, and that stimulates this process called gluconeogenesis. Let's break this down. Refers to glucose. You probably guessed that already. This this little middle part of the word neo means new, and genesis means origins of or creation of. So if we put all this together using those new meanings, we know that this means the creation of new glucose. And that's a process your body has the ability to carry out in situations where you have low blood glucose. Uh, you can use amino acids, you can use fatty acids, all those things, those bonds can be rearranged to form glucose if your body needs glucose bad enough. It also stimulates glycogenolysis. If you remember, the suffix lysis means to split. And really, if you think of it as the word hydrolysis, they just took the hydro off and added lysis. What's happened is glycogen, you can see the word glycogen in that word. Glycogen is being split up, lysis, into glucose monomers and then dumped into the bloodstream to provide fuel for whatever we need. It also increases protein breakdown. This is a term called proteolysis. If you look back here on my website, proteolysis, the prefix is protein. Again, lysis means to split. So it's the hydrolysis or breakdown of proteins into amino acids. So again, glucagon is going to could, at the very last, as a last resort, break down proteins to create amino acids. Then that would feed back into gluconeogenesis. You'd use those amino acids to create sugar to fuel whatever you need to do. But again, proteolysis is going to be a last resort thing in a fasted state. They'd much rather use your glycogen first, and then lipolysis. The prefix lipo refers to lipids, fats, triglycerides, and fatty acids, and lysis means to split. So it's going to stimulate. So glucagon, being in a fasted state, is also going to stimulate the breakdown of fat from your adipose tissues, or the release of fat from your adipose tissues. So again, lipolysis, lipid splitting, glycogen, olysis. I know I'm putting a weird emphasis in there, but it's just the splitting of glycogen. And proteolysis is the splitting of proteins into amino acids. And all these things, these processes can occur to either provide what's called ketone bodies, just fragments of fatty acids for energy, or they can use them to create new glucose through the process of gluconeogenesis, creation of new sugar. Now back on this animation here, so they do all that, they break those things down in order to bring your blood glucose levels to normal. But then say you had a meal, Alright, you've got high blood glucose. That's going to promote the glucose transport into cells. Insulin is going to bind with those receptors and cause those GLUT transporters to open up the doorways that allow glucose in, along with amino acids and other macronutrients that are in your floating around in your bloodstream. This stimulates glycogen synthesis, and that is a term known as glycogenesis. It's the creation of glycogen from the condensation or linking of glucose. Uh, Insulin also stimulates proteogenesis. Again, genesis means creation, so the creation of proteins from amino acids that are floating around your bloodstream, or it's going to stimulate protein synthesis. Lipogenesis. Insulin will also stimulate the creation of triglycerides from fatty acids or even extra glucose floating around the bloodstream. So again, back to this link here. Food intake, blood sugar rises, glucose goes into the cells, starts being linked together to form glycogen and glycogenesis. It's going to increase the uptake of amino acids to create protein and stimulate protein synthesis called proteogenesis. And it's also going to stimulate the creation and storage of fat through lipogenesis. So again, these mechanisms work hand in hand in order to maintain what's called glucose homeostasis. So I hope this helps. I know science sometimes the hardest part is learning all the terminology, so that was the purpose of this, to help you understand and break these words down. Prefixes, suffixes, know what they mean, they'll help you out. Have a good day.